Okay, now the back side of the notes. And the type of event and the sample coins, that should be a compound event because we have 2 or more events. All right. The cool thing is you can actually use a table to determine sample space like I had on the other side over here, right? So this time I'm just letters. It's so much easier to list because they don't form numbers. This represents, let's say I say this is 1 here and 2 there. So the first toss there are heads, and the first toss there are tails. Second toss here are heads, and the second toss here are tails. Okay? So my sample space would be heads, 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 tails, tails, heads, and tails, tails. So I prefer to write my sample space with capital letters when I'm using initials. All right, so flipping a coin twice. Is this different from flipping 2 coins? No, it's not really. They're going to have the same sample space. Now, one of the great ways to show sample spaces is something called trees. So a tree diagram, you have branches. All right. You probably always saw them looking at something like that. Okay. Well, each branch of the diagram represents one possible outcome. So this is one outcome, that's the other outcome. The set of branches, so both of these together represent the events. So what is the first event? Is it heads? No, heads is an outcome. The first event is the first flip. So we'll call this flip 1. What are the outcomes for flip 1? Heads or tails, right? Now I'm going to go ahead and have another event. So this is a set of branches event. Hopefully you realize that's the right number of branches. And I'm going to have flip 2, which is heads and tails. Those are the 2 outcomes for the second flip. Does my tree look right? Well, technically I didn't say I'm going to only flip again if I only did heads. I actually have to do the event in the case that I did tails. So it should look like this. So now you can list the entire sample space on the tree. Heads, then heads. Well, that's heads, heads. Heads, then tails. Tails, then heads. Tails, and tails. So a sample tree is a great way to get your entire sample space. All right, now I kind of goofed on the formatting here, so I apologize. I actually have spinner 1 on top, where this is the first spinner, and this is spinner 2. It was a formatting thing, spinner 1, spinner 2. I might change it next year. And I'm too lazy to write yellow, blue, green, so I'm going to do yellow, blue, green, white, and red. So the first thing I'm going to do is spin spinner 1. In all of these cases, I get a 1. For all of these, I get a 2. And for all of these, I get a 3. And the second spinner is colors, so I'll have yellow here, blue for these, green for these, white for these, and red for these. Got it? So I'm going to show you again. You can probably say, hey, I'm happy with this. This is a great way to generate the whole sample space. I would just do a bracket, commas between all those, and there's my sample space, right? The problem is, what if I had 3 spinners? Well, then it gets a little harder. So really what you want to do when you do a tree when you have 3 or more outcomes, you want to do a tree diagram. Because it would be too big, I'm just doing the 2 outcome tree diagram. Now I could go ahead and start my branches, right? But do I only have 2 outcomes on the first event? No, I actually have 3 outcomes, a 1, a 2, and a 3. So here's a 1, a 2, and a 3. I find it easier to write the outcomes first and then do the branches. For the second event, so this is event 1, this is spinner 1. This is event 2, spinner 2. And what do I have after spinner 2? I'm going to have colors. Yellow, blue, green, white, and red. So I actually have to connect this event this outcome with all the other outcomes. Same thing for spinner 2. It's not exactly lined up right. White and red. Have a sloppy tree. Voila. And then for my third spinner, green, white, and red. Barely fit. Now I can actually use this to write the entire sample space. This would be 1Y, 1B, 1G. Probably looks a little familiar, like my table, right? I could actually write it out like this, 1Y, 1B, 1G. I'm not going to write the whole thing because we have it right here already. So the interesting thing on some of your sample space stations that you did today, we asked if position, if order matters. And actually a better thing is the wording, does position matter? It depends on the question, right? So if I did here, I would say that yes, position matters because the first position is going to be spinner 1. I can't get a yellow. 1Y, I won't get a Y1. So order does matter. 1 has to be in the first position, Y has to be in the second. And there are certain problems, like if I have first place or second place for a race, their position does matter very much to the person who got first and very much to the person who got second. But if I'm doing handshakes, it doesn't matter what side of the handshake you're on. Both of you are participating. So hopefully that'll clear up some of your questions on position matters.